All right, students, here's your 1.3 notes, solving equations. Please make sure you have a title and your name, first and last name, and pen. Go ahead and copy all of this down. So pause the video, copy it down, and we are going to go ahead and get started. This is 1.3. Our essential question is how can you solve equations that have variables on both sides? Okay, so yes, occasionally we are going to write out steps, not all the time, very similar to what we did in 1.1 and 1.2. The first thing that you want to do is take a look. You have variables on both sides, so we need to be able to bring the variables on the same side. And I'm actually going to add 3x because I want to keep x positive. That kind of eliminates an extra step. If you want to take the 5 over and make it become a negative 5x, that's fine. Again, you may need to make sure on the left-hand side you have a variable. I'm sorry, on one side you have a variable, and on the other side you have a constant. So we end up with 8x equals 24. Divide by 8. Final answer, x equals 3. Okay, that's what we're going to be doing. Let's jump into some problems that are a lot more complex. Okay, not only do you have variables on both sides, you have constants on both sides, you have a fraction, and you have parentheses. Students, I know you can do this. Okay, I'm confident that you can do this. So, first thing you want to do is, remember I said, anytime you see parentheses, let's go ahead and distribute. Okay, we are going to distribute that 1/4. Now, please do not be scared. You can change this 32 and this 56 into a fraction. That's fine. Remember, when you are multiplying fractions, you are multiplying across. You're multiplying the numerators and you're multiplying the denominators. Okay, and then you can simplify. So 9x minus 12 is equal to 1 times 32x is 32x. And 4 times 1 is 4. Plus, there's another set that we need to multiply it by. 1 times 56 is 56. 4 times 1 is 4. And those can actually be divided out. You can actually divide numbers out. Okay, so let's go ahead and do that step and bring down that 9x minus 12. Let's simplify this. 32x divided by 4 gives you 8x. Plus, let's simplify this as well. 56 divided by 4 is 14. Okay. Once you've done that, students, take a look at what you're left with. This looks very similar to what we did up here. Okay. We need to move, again, I can take this 8x and move it over. We want it on the opposite side of this equal sign. If I bring my x's to the left-hand side of the equal sign, then I take this negative 12 and I'm going to move it over to the right-hand side of that equal sign. Some teachers or some students are familiar with the railroad track and crossing, and if you want, you can do that. But on one side, you need the variable. On the other side, you need the constant. It doesn't matter what side. Okay, so I'm going to bring this 8x over, and I'm actually going to subtract. That gives me x minus 12. Actually, let's go ahead and I guess we can write that out. I'm going to show you step by step. If you get comfortable, you can already add the 12 to both sides. Final answer, x is equal to 14 plus 12, which is 26. Again, I know it looks like a very complex problem at the beginning, students, but if you just slow down, organize, look at what's in front of you, I'm confident that you can do this. Okay, let's do it again. Now we have double parentheses on both sides, so we have to distribute. Okay. We can make this into a fraction, both terms into a fraction. And we're going to take this 3 and we're going to multiply here and here. No fractions for this second set of parentheses. All right, so now remember, you're multiplying the numerator. So we have a negative 3 times 8x. That gives me a negative 24x. 4 times 1 is 4. You can write this as plus, but don't forget you have a negative. So negative 3 times 12 is negative 36 over 4 times 1, which is 4. Okay. Distribute 3 times x is 3x. 3 times a negative 3, you can put plus negative 9, or you can just simply put minus 9. Okay. Now, again, these can actually be simplified. Negative 24x over 4 is negative 6x. Plus a negative 36 divided by 4 is negative 9. That's what we get here. And that equals 3x minus 9. It's up to you. You can bring that over. Let's bring the negative 6 to the right-hand side, because you can do that, students. Let's do it. Let's switch it up a little. So I'm going to have to add 6x. Negative 9 is equal to 9x minus 9. Now, no matter which route you decide to go, you're going to get the same answer. You end up with 0 is equal to 9x. Divide by 9, divide by 9. And x is actually equal to 0. All of that, and you get 0. X is equal to 0. Okay? I put stars next to B and C. Those are complex equations. Okay? All right, the last two, last but not least. Remember, our essential questions is, how can you solve equations that have variables on both sides? We have been solving equations. Okay? Now, example 2, and I believe this is our last example. It is. Identify the number of solutions. You're going to do the math stuff, right? You're getting in the groove. You're figuring this out. You're saying, hey, if there's parentheses, let's distribute to both terms. Watch what happens. 12x. 4 times the negative 1 is negative 4 is equal to 12x. And then you're like, oh, let's move the variable on one side and, let's solve. Let's say you want to get rid of this 12x, so you want to move it over. What happens? It disappeared. Look at that. Our variable disappeared. And then you're left with constants. Take a look at that number. Read it to me. Negative 4 equals 0. Ask yourself, does negative 4 equal 0? No. Because we got our variable disappeared. If this is not a true statement, you put a slash through that equal sign and you write out no solution. And that's your answer. Students, if you take a look at these problems, these all have one solution. X equals a number. Not multiple numbers, a number. Okay? 3, 26, 0. 0 is a number. But when your variable, when your letter disappears, and it's not a true statement, if you don't have a true statement, we call that no solution. It's not true. Let's take a look at this one. I'm sure some of you already figured out what's going to happen here. Take this 7, let's distribute it. I'm going to write this down. 21 minus 7x is equal to 21 minus 7x. Okay, again, if you're thinking of moving the constants or the variable to one side, say we want to move this positive 7x over positive 7x. Oh, look, our variable disappears. We're left with constants. Ask yourself this question. Does 21 equal 21? Yes. So that means we have something called many solutions. We also have something called all real numbers or infinitely many solutions. And I'm okay if you write down many solutions. If it's a true statement, if you maybe got rid of the constants and you're left with negative 7 is equal to negative 7x, that's a true statement. Negative 7x does equal negative 7x. Or x equals x. It's a true statement. So we call that many solutions. So here we are. One solution. No solution when it's not a true statement. Many solutions. Go ahead and start your homework.